Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott.
And in studio with us we have Owen. Owen, if somebody needed to contact us, what would they need to do?
For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemath.net and on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. So, Owen, where do you go to school and what grade are you in?
I go to school at Stockdale Elementary and I'm in 4th grade.
How is 4th grade?
It's good. I really enjoy GATE.
Oh, good. So that's something extra that you do in 4th grade.
Yes.
So what is that? Can you explain that a little bit to us?
It's
for kids that aren't in it?
Enrichment program.
And what kinds of things do you do in that program?
More interactive and hands-on stuff.
And you like doing that?
Yes.
Good. I understand that you also learn some different languages while you're in that program.
Yeah,
What are you
4th
working on
grade
right now?
is Italian.
And do you know what will be coming up, or are you just focused on the Italian right now?
I think in one of the grades we're doing like French or something.
That would be 6th grade.
Yeah, I think we're sticking to like the Romance languages.
There you go. So good. I'm glad that you are familiar with that and that you know that those are the Romantic languages and that they are intertwined with each other. And you'll see how working with Italian one year will help you with Spanish, will help you with French, and you'll see how they're all
because
connected.
there are words that look and sound the same. I don't remember like the exact word for it, but
Cognates.
yeah, cognate.
There you go. Well, good. I'm glad you enjoy that program. So what kinds of things have you been doing in math?
Well, right now we're working on generating equivalent fractions.
Do you know the easiest way to do that?
Yeah, you multiply the numerator and denominator each by 2.
Could you do it by any other number?
Yes.
You could do it by any number, actually, couldn't
Yeah,
you?
but that's kind of unnecessary if you're just gonna try to do it like the easiest way.
Right. Hey, you know another way that's very easy?
No.
Let's say I had 2 over 3.
Yeah.
You would say multiply both of them by 2 and you get 4 over 6.
Yeah.
How about if I just put a 0 at the end of the 2 and the 3? I made it 20 over 30. Would that still be equivalent?
I've never thought of that.
Maybe we'll take a look at that later on today.
like
You want to do that?
Yeah.
All right, well, we'll do that in a little bit. But first, just a reminder, we do have phone tutors available most Tuesdays and Wednesdays throughout the regular year from 3:30 to 5:30. Phone numbers are at the bottom of your screen periodically throughout the program. Before we get Owen started, let's first take a look at today's Math in the News.
Okay.
All right, so I know you're a rather inquisitive young man, so I'm not going to put up on the screen yet all of the information that I've got, because I'd like to first find out what you think.
Okay.
Sound good? So in mathematics, it's recommended that you use a pencil, correct?
Is that a mechanical pencil that's
Indeed
made
it is.
to look
So we
like
have both
a pencil?
kinds, right? So we
Okay,
have a regular
nice.
pencil and a mechanical pencil.
Okay.
Do you have a preference on which you use?
I Mechanical pencils, the lead breaks kind of often and the writing's a little too thin, but I like them because like they don't have to be constantly sharpened and they're easier to just like hold sometimes.
Okay. So you like the way they feel when you hold them.
Yeah, like the plastic.
But you don't
feel.
like how it's thin and breaks sometimes.
Yeah, so I prefer to use the regular pencil.
The regular, like when we grew up, there were no mechanical pencils.
Yeah.
There were
Right.
just regular pencils. Do you have any idea how many times a regular pencil like this can be sharpened? On average, how many times this can be sharpened before?
I would
it's-
say 250
Whoa.
to 450 times.
That's a lot of sharpening right there.
Like,
Maybe that's
how much?
total
till-
rotations,
There you
maybe.
go.
But let's say I sharpen it. Let's say it takes 6 turns. That
Okay.
counts as one-time sharpening.
Okay.
All right. You still good with the?
Then I would go into like 190-ish to
All right. So 190 times you could
200, like
sharpen this
20-ish.
pencil.
Yes.
Considering one tree,
Yeah.
one cedar tree, how
Hmm.
many pencils do you think can be made from one cedar tree?
Well, I don't really know how big the average cedar tree is. How big would it be?
Well, think about the trunk.
Okay.
Right, this is where you're going to get most of the wood from. All right, so think about school. You're out on the playground, you see
Yeah.
one of the trees out there.
Okay.
Just take one of those
Then
for
I
instance.
would say you could probably make like 70 to 120 pencils with one tree.
An excellent guess right there.
There you go.
So we're going to take a look. I found this article online the other day.
But like pencils are smaller than they look because of the graphite put into it. I find it interesting that they still call it lead when it's graphite
Right, it's
because
graphite, right? A lot of
lead
people
was
say that. Well,
found
they got
out
the
to
lead in
be
there.
like
Well, it's
very
graphite.
dangerous.
Right,
Yeah.
because lead could be dangerous.
Yeah.
You don't want to get lead in you.
No, you don't.
But graphite, it's a different story.
Yeah.
Did you know
But
there was a
I
best mechanical
wouldn't
pencil for
mo-
math?
Ooh,
No, I
wanna hear
didn't.
about
Here it
this.
is, right here. The best mechanical pencil for math lets you write intricate equations clearly and
Pencil.
precisely. So you know how you were talking about the graphite
Yes.
being thin and breaking?
Yeah.
This is made specifically for that. So 0.2 mm. Do you have any idea what that means? 0.2 mm.
I'm guessing it's millimeters.
You are correct.
Okay.
So how about reading decimals? 0.2. Do you know what that is when you say that mathematically?
It means it's less than 0. And 0.2 would mean it's like,
Well, less than 0 would be a negative number, so it's still a
Yes.
positive, so it's less than 1.
yeah, sorry, less than 1.
So 2/10.
Yes,
You've heard of tenths before and hundredths
Yes.
and things like that? Okay. So this pencil, the Pentel Orange or whatever, is the one that they say is the best for mathematical uses, right? I saw that, I'm like, how do you get a best pencil for math? And the reason is because of how it writes and how they say the lead doesn't wear down,
Cool.
okay, because of the sleeve in it. Graphite pencils are classified, the ones that you like using, right, are
Like-
classified as soft black, hard black, and firm.
Like the number 2?
Correct.
Right here?
And that's why there are different numbers on those as well.
Okay.
So to the degree of darkness with which you can write, which is why a lot of times artists have a lot of different pencils
Yeah.
with different numbers on them. Because those that know what they're doing with them, instead of us, it just
Makes a
yeah,
difference.
well, pencil's a pencil. We'll
Yeah.
go ahead and go to it. So here we go. On average, a pencil can be sharpened 17 times.
Oh.
So I didn't even think it would be that many times.
Yeah.
Like, I. Like,
So your pencil,
would
where's
it
that?
be
You have to
like
sharpen it.
from like
Brand new.
broken, no lead to sharp? I poked my finger.
Correct.
Oh, I thought it would just be like it's worn down one thing.
Almost.
Okay.
You can draw almost 35 miles with a pencil.
Whoa.
That'd be a pretty long line.
That's
to
right.
go
So
ahead and do that
if I were to like crouch down and start walking slowly with a pencil trailing behind me,
what
I
would
could
be an easier way to do that instead of crouching down to do that?
I'd get a really, really long pencil.
Or could you get a yardstick and tape the pencil to the end of the yardstick?
Yeah,
use
that'd
that?
work.
Because I don't know if we're going to be able to find a long pencil. Because then it wouldn't be an average pencil. You might be able to go
Yeah.
a lot longer
Yeah,
than
100 miles.
35 miles
That's
with
right.
that.
Okay.
300,000 pencils you can get out of one tree.
Whoa.
That I
We're a little
found
low on the guess.
remarkable right there. So anyway, I didn't know there was a best pencil for math until yesterday when I found the article, and obviously there is. So for all of the serious math students out there, the mechanical pencil has been proven to be the best pencil for math, and that is today's Math in the News.
Do we have one here now?
Oh, I don't have that kind of money to buy the best pencil for math. Are you kidding me? Look at what we've got. We've got the old number 2, the HB, Sanford, and I think you can pick these up
The dollar store.
a dozen for $1
Yeah,
maybe.
that's right.
So anyway,
And the clip that holds it
gonna
in
be a
your
rough-
pocket is
but-
broken.
Ah,
I
that's
do
the
have
pencil we want.
the classic Do the Math pencil right there. And,
Oh,
I know
those are
that's gonna be
fancy.
hard. And you have one now also, right?
Yeah.
So
Well, I
the
didn't
Do
bring
the
it
Math
in here. I
pencil,
think it's like,
there we go.
I think we left it at the front desk.
This one's got power in it.
That one's only for math. If you try to do English with that one, big troubles. Yeah,
You ready to get
doesn't
to work?
out very well.
Okay.
All right, over to the board, young man. All right, so we're just going to take this right out of your book.
Okay.
So you want to tell me if these fractions are equivalent or not.
Okay.
So choose a number between 5 and 12, Owen.
I'll do 9.
9. All right, problem number 9 is 5 over 6. Well, you can erase the 9, because that's just problem 9. 5 over 6. And how about if you erase the 9, and we're going to go to the left of that so you don't run out of space on the right side.
Okay.
All right, so to the left of that, leave a space. There you go. 10 over 12. And then explain to Scott if those are equivalent or not and how you know.
Oh.
What do you think? That's wonderful. Looks good. Okay, that'll work. What do you think? Are these equivalent fractions, Owen?
Well, 5 and yes, because the strategy I think I may have explained earlier, I don't know. If you multiply each number,
What are you multiplying?
each of the numerators and
You're
denominators.
going to multiply 10 and 12?
No,
Oh.
the numerator by numerator, denominator by denominator by 2.
So I just want to be clear what we're multiplying by 2. Which number are you multiplying by 2?
The denominator. Both of them.
Right, but which ones? We have a
So-
numerator here and a denominator in the first fraction, and we have a numerator and a denominator in the second fraction, right?
So the numerator by numerator, denominator by denominator.
Okay.
And we'll multiply each of them by 2. If you multiply each of them by 2, then you will get an equivalent fraction.
Okay.
This will work with any number, but 2 is
So
the
show me how it works in
easiest.
this specific problem.
Well, 5 times 2 is... 5 times 2 is 10.
Uh-huh.
And 10 times 2 is 20, but you always find the one that equals the other number.
Gotcha. So let's see if we can come up with a theory or a rule about how to go about finding some equivalent fractions.
Why not
you said you could
multiply
multiply both
the-
of them.
The smaller number by 2.
There we go. That's a good
Okay.
a good way to go about it. So we're just going to multiply the smallest fraction by 2 to
Okay,
see if it
so
equals exactly the
5
largest fraction, right?
times 2 equals 10.
That's true. So is that a good thing or a bad thing?
That's a... Well, doesn't really make anything, like, if you're in favor of them being equivalent, it's good.
Okay.
If you're in favor of them not, it's bad.
Okay, that's fair.
So 6 is the smaller number, so we would do 6 times 2. That's 12.
Mm-hmm.
So these are equivalent.
Gotcha.
Which
So they are
means
equivalent because if you multiply both by 2, then you end up with this new fraction over here.
Yes.
Right. Now, how did you choose that number 2? Because I've heard you mention it quite a few times.
Because it's the lowest number, it's an easy number, and you can do this even if you only know addition by adding the two numbers.
That's a great idea. Is it the only number you can multiply by?
No, you can multiply it by 1,000, and I don't think it'll change, but it will be a lot more work.
A lot bigger, yeah, a lot bigger. And it may not end up with the fraction you're looking for here, right?
Yes.
So whatever number, being able to go to that number, here's one way to look at it. You told me at the beginning, or actually at near the end of the problem, that 5 6 is equal to 10 12, and that's what we're trying to figure out, right? So if you wanted to make 5 into 10, you would multiply times 2.
Yes.
If you didn't know the 2 number, though, we could do it the other way. What's 10 divided by 5? What is 10 divided by 5?
10 divided by 5 is 2.
That's right. And so that's the number you're going to multiply by.
Yes.
If we happen to have a 15 here, and you did 15 divided by 5, you could multiply times 3 on the top and the bottom and see if
Yes,
it would
you
work.
could.
So that's one way to think about the number you might want to try to see if they're equivalent or not.
Yeah, and there's actually a different way you can do this that may be easier for some people.
You want to try it on the next problem?
Yeah, sure.
Okay, sounds good. I'm sure there's another one left for us, right? Uh-oh. Careful with the board there.
Too good.
Good
Yeah,
job.
he went a little outside the edge, that's why I didn't.
There you go.
So this one, hot shot, since you already know your equivalent fractions, I've got a word problem for you now.
All right.
Mira painted equal sections of her bedroom wall to make a pattern. She painted 2/5 of the wall white. So 2 over 5 is white.
You're fine. 2
And
over 5.
1/2 of the wall lavender.
Well, interesting.
And you can probably get your circle out of there because we're not comparing these ones.
Okay.
So you have 1/2 lavender and then 2/5, 2 over 5 is white.
And we want to be able to compare these two fractions to see how they're going to do, right? So the other one is 2/5. You can write that one down as well?
You want to write an equivalent fraction for both of them using a common denominator.
Okay, so the idea here, Owen, is that we can't really compare these two fractions to see
So-
if they are equivalent or not because they don't have the same denominator.
So first we need to find the numbers that will be multiplying.
Tell me what the least common denominator is of 2 and 5. What number would you like to change for the denominator for each fraction?
Well, I don't know it off the top of my head, but
Well, what's one way you can find a denominator? So you're going to go with some multiples of those numbers?
yes.
Okay. Well, I kind of want to know what's going on in your head because I'm really
Oh,
curious
wait,
about your
I'm
method here.
doing something different, I think. But my theory, if you go,
If you
if
list
you-
the multiples,
if you list these long enough,
Mm-hmm.
in theory, there should be one number where they're the same.
that's true. Yeah, that's definitely one way to do it. 6, and you probably don't have to go any higher than 10. What's the next one after 6? I'll give you a little bit of room here.
8,
And what's after that?
10.
Good. So I think you probably found your number there, right? And if you went back to look at the numbers 2 and 5, how could you come up with 10? You just multiply them together, right?
Yes.
So that's one way to do it. You could multiply them together, but the way you did it here, you can kind of see that really is the lowest one we could possibly have.
Yeah.
So now your task is this. I would like you to make a new fraction with 10 on the bottom that is equivalent to 1/2. And I'd also like you to make a new fraction with 10 on the bottom that is equivalent to 2/5. And then we can compare the fractions to see if they are equal or one is larger than the other, okay? And you can leave that there if you want to. I always like to see where it came from because we want to know why you have 10 in the first place. So can you work on this one first? What are you going to multiply this by? We like the color you're working with there.
Yeah,
What are we
that's
going to multiply
something
1/2
pretty close to science.
times, right? We want to multiply this times something in order to get a new equivalent fraction. So think about this in your head. I know you're a good problem solver. 2 times what number equals 10?
2 times 5 equals
Gotcha.
10.
Can you put that 5 right there?
Yes.
Good. So if you multiply it on the bottom of the fraction, the denominator, you have to multiply it on the top, just kind of like you were telling us earlier, right? It's okay. We love the color you got. Okay, we want to stick with that same color so we know which is your writing and which is my writing. Okay?
Okay.
We'll put some dots around here. So if you multiply on the bottom times 5, you got to multiply on the top times 5. Can you show us that real quick?
That would be 5.
There you go. So we have 5 there. So this new fraction, 1/2, is equivalent to 5 over 10.
Yes.
Let's see if we can compare that to the fraction we have over here. This one is 2/5, but we want to make it into a fraction with 10 on the bottom. Would you agree? Mm-hmm. So 5 times what number is 10?
Well, 5 times 2.
2. Can you write a 2 there? Good. And so it has to be multiplied on the top times 2 as well. Would you agree? So can you show us that as well? And we want to show this part right here, times 2, right?
Yes.
So now we have new fractions we can compare. Here's one of them, 5 over 10. Here's the other fraction, 4 over 10. And even though your numbers are in dots, we can still see what the numbers are, right?
Yes.
So now you can compare those two. What was the ultimate question that story problem actually asked us? Do you remember?
Ultimate question, I don't remember.
Let's go back to the book. What is that
Right,
question?
so that one, they wanted an equivalent fraction using a common denominator.
Gotcha,
Which you
okay.
guys have got. So
And
nicely done.
Yep, good work.
You guys came up with 5/10 and 4/10. Nicely done. Just a reminder, we do have phone tutors available until 5:30. We'll be back with more right after this.
I'm Nancy Gordon. I'm the Director of the Health, Safety, and Wellness Department with Panama Buena Vista School District. This is another tool of mathematics, a Snellen vision screening tool. So oftentimes as you come onto a campus, you will see this vision box located either in a health room or in a classroom if we bring in the students to have their vision taken. You will see on this chart the numbers or the letters. You can see it in both ways. They start a little bit larger and then they work themselves down. You'll hear folks speak a lot about what's my vision acuity. And what we're looking for with students is a 20/20 vision. We want to make sure as students are sitting in those classrooms, they're able to see the board and also see the material in front of them as they're reading their books. So we have students come into a room with our nurses on staff, step about 10 feet away, we'll put a marker on the floor, and then we'll have them cover one eye. And then as they're covering that one eye, we are checking to see the acuity in the eye that's exposed. So when we're looking at vision screening, we want to see again that 20/20. And when you look at this chart, the markings are over to the side. So 20/20 is all the way down here, which is where we want students to see. And when you're looking at that for vision, you want to be able to say at 20/20, that student's able to see at 20 feet, and they're seeing this 20 sized graphic that's provided on the screen. So as you are unable to see those, we'll ask you to go up line by line until we're able to identify that you can see that line with clarity. So once we know that that's where your vision is, if it's in a zone that we feel like you may need some support so that you're seeing that much more clearer, we will have your parents take you to your eye doctor and have your eyes checked. Again, this is another tool that we use in the school setting to screen our students' vision so that we make sure you're able to see as you're in the classroom.
And once again, a big thanks to Nancy Gordon and the nursing staff at Panama Buena Vista Union School District for another Tools of Mathematics right there. And do you remember taking eye tests when you were young?
Oh yeah, cover one eye, and cover the other eye.
Fun stuff in school. Anyway, we do have phone tutors available until 5:30 most Tuesdays and Wednesdays. We have 4th grader Owen, a student at Stockdale Elementary, in studio with us. We also have some math problems we need to take care of for Jocelyn, who emailed them into us. So Jocelyn, we're going to do a couple of them right now. I already did some for you and sent you the answers to those, but here's some that we didn't do yet and sent you back the answers. So here we go. 6 plus 8, open parentheses, x plus 2, close parentheses, is equal to 6. And we'll do that first one.
Gotcha. All right, Jocelyn, we want to figure out, ultimately, right, your goal is to figure out what value of x would make this equation true. What number could you put in here? And when these equations are nice and simple, you can usually do a little guess and check. But in this case, we want to see if we can really go through the process so that when they're complicated like this or even more complicated, we can go through and have a definite route to get to the end answer. What I always like to do when I first start is put a line right down the middle. It divides the equation into 2 halves. And then I remember to myself, if I do something to one side, I have to do the same thing to the other side. The first thing we're going to do here is see if we can simplify the left-hand side. 6 is going to stay just like it is, but we're going to use the distributive property and be able to get rid of these parentheses here. So the 8 is going to be multiplied times each thing on the inside of the parentheses. So 6 plus 8x plus 8 times 2 is 16, and we still have a 6 over here. The next thing I'm going to do before we start moving things back and forth and around the equation is go ahead and simplify this part. So we'll put the 2 numbers together because we can put those, they can be combined on the same side. So the 8x is going to stay just like it is, and 16 plus 6 is 22, and we're left with 6 here at the other side. Now we want to see if we can shift that 22 to the other side because we want to combine all those numbers together. Just like we combined on this side, we want to put these together. But the way that you do that is to do the opposite of what it says here. It says to add, we are going to subtract 22, and again, that's why I put that line down the middle, so I remind myself, if I subtract 22 on the left, I also have to subtract 22 on the right. That's really important. We subtracted 22 because we want those numbers to go away, and on the left-hand side, we're left with 8x. On the right-hand side, we now have 6 minus 22, so I can tell you for sure we're definitely going to have a negative number. And you can flip those around. 22 minus 6 is 16. So hopefully you're pretty good with positive and negative numbers. It's pretty important stuff. The last step that we have to do in this problem, this expression at the very end, or this equation at the end, says 8 times some number equals negative 16. And again, you can probably do that in your head, but the mathematical way to do that is to do the opposite of what it says here. It says to multiply, so we are going to divide each side by 8. And each side, when you do that, these 8s will cancel out. In other words, 8 divided by 8 is 1. So at the very end of the problem, you have x equals negative 16 divided by 8 is negative 2. Now, one thing you can do at the very end of that problem, Jocelyn, of course, is you can take that number, plug it back into the original part that we have up here, and make sure it works. And that would be a pretty darn quick way to do it, because if you put negative 2 all the way back up here, negative 2 plus 2 is 0. 8 times 0 is 0, and 6 does equal 6. So we know that problem works.
There you go, nicely done. So erase that, and we're going to do one more for her.
Okay.
And this one I selected because of the second part. So let's go ahead and write down the first part. 2 minus 3, open parentheses, x plus 4, close parentheses is equal to 9, minus, now open parentheses, 3 plus 2x. And the reason I wanted you to do this one is because of the negative symbol outside that parentheses with no number outside of it to multiply with.
Yeah,
that is stated.
Yeah, and that happens often with, I know it's happened in many cases in my classroom with my students, is that we don't know how to get rid of those parentheses because there's no number in the front. We want to know what that number is. So on the left-hand side, we're going to clean this up a little bit by multiplying the 3 times x and the 3 times 4. However, it's not just 3. Please remember that when you're doing the distributive property, you got to take the sign that goes with 3. So the 2 is going to stay the same. Negative 3 times x is negative 3x. Negative 3 times positive 4 is negative 12. And the left side no longer has parentheses. All right, we're going to stick with that 9 there. And then here is the part that students often get confused on. We love it when there's a number in front of those parentheses. In this case, there isn't a number. But I would contend that there really is a number. We just don't see it. And so if you ever don't see a number here, sometimes students will say, we want to put a 0 there. But if you put a 0 there, we have all kinds of issues because this whole thing would go away because 0 times anything is 0. Really what's happening is there's a 1 there. Because 1 times this stuff wouldn't change the value, and now we can multiply the negative 1 times the 2 things on the inside. So let's see if we can get rid of those parentheses. Negative 1 times 3 is negative 3. Negative 1 times positive 2x is negative 2x. Just like the last problem now, we're going to combine the things that we can put together. So in this line here, we're going to put these together here. We'll have negative 3x, 2 minus 12 is negative 10. On the right-hand side, we're going to combine these 2 things. They happen to be in order for us, which is kind of nice. 6 minus 2x. All right, they're not exactly the same, so we won't have any strange issues going on. In my world, what I really like to do is I like to get the letters on the left and the numbers on the right. You could do it the other way around. It doesn't really matter how you do it, but I love to get those letters over here on the left, so I'm going to move the 2x to the left-hand side.
See, now I personally would have done the other way, so I have a positive x.
I thought so. And a lot of people like that too. The reason that I do it this way, and this is again just personal preference, you can have a positive by moving the 3x, that wouldn't be a problem. I like it this way because when we eventually do inequalities, when you go to graph an inequality, we love to have that letter on the left because when you graph it, you can follow the arrow. This happens to be something that I like to do. So in this case, we have negative 1x minus 10. And over here, the x's have gone away and we get a 6. So far, so good. Jocelyn's right here with us. We're going to add 10 on the left side. Negative 1x equals 16. And if we'd have done it the other way,
this is why kids need to remember
That's right.
that if they like the x on the left, it's all fine. Just remember
there's one extra step
to take care of that negative.
Yeah, there's one extra step. And so you'll notice when I did this at the when we moved the 2x over here, I had a negative 3 plus 2. I didn't just write negative x. I wrote negative 1x because that's really the value in front. Kind of goes along with the theme we had at the beginning of the problem. At the very end here, we're going to divide by negative 1. And x equals negative 16. And of course, there's an answer. You can go back to the beginning and check it out at the original equation.
There you go. Nicely done. Thank you for that explanation. And I do appreciate that you were able to explain how we put the negative 1 out there, which is why I selected that problem. And always students see a 3 and they forget the negative symbol in front of it. Always keep the symbol with the number. Jocelyn, hopefully that helps you out. And for emailing us those couple of questions right there, you've got yourself a couple of tickets to CSUB Athletics. So congratulations on that. They just started basketball season this week. And volleyball season is wrapping up, and swimming is still going on, wrestling will be going on, baseball, softball coming up, so you're right at the beginning of the season for CSUB Athletics. Whatever athletic event you'd like to go to, you have a couple of tickets courtesy of CSUB Athletics Department. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. We'll be back with Lorena from the Bakersfield Museum of Art right after this.
This is probably This program right here is the only one in miles around. The only one is, the closest is about 100 miles from here, San Luis Obispo, so there's no classes around here. So I really recommend this class. All the old bodymen and technicians are retiring. So there's a good chance that they're going to get a job on this field. We do. You know, the first semester, I train them. I train them how to do the sanding, the primer, masking. The first semester, the second semester, they will be placed in community class. I believe there is an open enrollment, ROC webpage, and you can enroll and you can choose any program the student wants. And also there's another way, either the counselor, the school counselor on the comprehension school, they will choose the class for them.
Yeah, like it could help you get prepared for the future.
I totally recommend this class for other students. It's fun, the environment's good, and just overall, it's a really great class, and I enjoy it. Thank you.
I wanted to learn more about like cars and how to fix them.
My expectations for this class was work on cars, like how you see my teachers and my classmates behind me, and well, hopefully get my own car and work on it on myself.
And big thanks to all the staff and students at ROC and CTEC for providing videos for us this entire season as well as last year, all self-produced at the CTEC. 636-4357 is the phone number. We do have Lorena from the Bakersfield Museum of Art in studio with us today. And Lorena, what is your role with the museum?
Hi, I'm an art educator at the Bakersfield Museum of Art.
And how long have you been with the museum?
I've been there 7 years.
7 years. So you've seen a lot of students come through and a lot of art activities.
Yes, I have.
All right, what will you be doing today?
So we're going to be creating, we're going to weave using a number pattern. So we have, again, different materials. We're going to be using yarn. Here's an example. So we're going to think of a number pattern, right?
Yeah.
So an example, how many can you count here? So blue lines.
I see 6.
6. So I have 6 here, 3 here. Kind of creating stripes, right? We're going to create some stripes.
That's nice.
So to create, so when we use Weaver, you kind of use a loom. We're going to use cardboard for our loom today. And to create this is very simple. We use, again, a ruler. We measure our slits. So these are about 1 centimeter long. You see that? We're 1 centimeter. And then we make little cuts. And then we just wrap it around with yarn, again, to create our loom. Have you ever heard of a loom?
Yes, I have.
Yeah. So we use yarn, again, to get our fabric. So you want to pick your colors?
Okay.
So I'll pick maybe this green one. It's okay.
Okay.
Then we're going to push it through.
And tie it. Kinda.
Kind of want it to hang a bit.
Yeah,
So it's like this. And then do you think of your pattern, your number pattern they're going to be using?
yeah.
Yeah, okay. So to do our, again, our stripes, we're going to go over, or under, over, under, over, under, over, under, over, all the way through. And then just push it out. And you kind of want a tail at the end. See how this one has like a tail?
Yeah.
And you want to push it all the way down. So with your fingers, you could push it down. How's it going? Okay, good. It's okay if it gets stuck. And then you're just going to go under.
Over.
You want me to?
Okay.
Did it get stuck? Okay.
And back.
Let me see. And then you want to pull it. You can have that little tail at the end over here.
Okay.
And then we're going to do it again. So over here we went under. So we're going to go over this way, over, under, just like that again.
Okay.
And you're going to do that as many times as you'd like. Maybe my pattern is going to be 3, 2, 3, 2, 3, 2.
Okay. Do you know where this like originated?
I think it's all around the world. We see it in a lot of African art.
Okay.
When creating, we saw it in a lot of Native American art when they create baskets, blankets. This is called textile art.
Okay.
So we're creating kind of like a little coaster. So using yarn, we're going to create some form of fabric. And then I'm going to go over again, under, over, under, over.
Like this? Do I curve it at the last string?
So now we're going to go under.
Uh-huh, yeah.
So on this side,
I'll put it on the needle and then under, over.
go under, over, under.
Okay.
And then when you're ready for a new color, we're going to push it down. How's it going?
Good.
Good.
Fourth grader. Wow. Super well spoken.
So I have 3 already.
Huh, good.
Are you still going to go with the
I'm
yellow?
working on my third.
You want to pull it all the way through. So maybe this over here, pull it.
Look, it's so
Okay.
Perfect.
really.
Do you want to pick a new color or you want to still add
I'm
yellow?
gonna do more yellow.
Okay. And it's okay if it comes out of the needle, you could just pull it back through.
Is that the last art project we did? Like the Do the Math did?
The one on the TV?
Yeah.
I'm not sure. But again, that one has patterns too, right? You see there's
Yeah.
using, again, vertical lines
My
and
friend
horizontal
actually
lines.
did that one.
Yeah.
It's the one he did for the show. And is each of like the yarn, is it supposed to match each other?
So you could do patterns like how I did here. Yellow, And then
Like
over
I'm
here,
saying, are you
green.
supposed to fold it the same way or a different way? Like the under over,
So you want to put it the other way. So you go over,
under.
over, under, over, under.
Okay.
So you're repeating.
Under, over. Okay.
Got it? Yep. And you want to pull it, make sure it doesn't come off the needle. Good.
And then for the next, you do.
And I'll add my yellow. And I'm just going to do maybe three colors. And then repeat that.
I see. How many is your line gonna be?
I'm going to have, I think, 3 colors.
Okay.
3 colors.
Like how many per 3?
3
Okay.
lines, yeah. But if you want to add more, you could.
Yeah.
And I'm pushing it in.
And what would you recommend to use this as when it's done?
So you could use it as maybe a coaster
Okay.
or a wall decoration.
Okay.
We currently have an exhibition at the museum. We have an artist who uses weavery. She's a textile artist, and she makes really big work. So it could be something. We're doing something small, but imagine like as big as a table.
Oh.
So again, over, under.
Does
So you see I have 3, 3. So I'm going to go with blue and add 3 more lines.
do they like make specific like abstract things like a sunset or something, or are
They do. You can also
completely abstract?
Yeah, so it's one of her artworks just called horizontal lines, because we're making horizontal lines, right?
Yeah.
It's very abstract, but you could kind of see elements of nature. So you could see, again, you could create, like I think
Like
earlier you said
there's
how
like
you wanted
the
a sunset.
yellow, and then like the greenish, and
as
the
land.
blue.
Yeah, so you could also
Like
create
the
like
yellow, this green,
like a painting with it,
the-
right?
Yeah.
So you
and
could
then
create-
like the other green, and then the blue.
So if you're
Okay.
thinking like I think earlier you said you want to create like a sunset.
Yeah, that's
so
what
you
I'm
would
doing
use-
now. The yellow is gonna be the top sky,
Uh-huh.
and then the bluish, and then the blue, the bluish green, the green. So yeah.
Yeah, that'll be nice. You can also make a lot of geometric shapes with these. So like a triangle, you just have to go towards, those are more harder to do those kind of shapes, because you really have to think of, you're using 2, 2, 2, 2, kind of like a repeating pattern as well.
Okay. Does the artist, does she do any of the like the triangle-ish patterns?
She made kind of like a flower shape, like a geometric flower shape.
Okay.
And it's very large. Like I said, she works really big.
Okay.
Also, again, she made like an abstract piece using, again, greens. Things are colors of nature, right? Greens, blues.
Okay.
Stuff like that.
Somewhat like the colors we have here now?
Yeah.
Okay.
And here's 3. How's it going? Nice. Good job. I'll stop here.
What do we do when we're like done with it? Just like let it
Yeah,
hang
just let it
off to
hang,
the
and then we
side?
can always tie them together and create kind of like a.
Okay, can I have
nice
one of the
display.
yellow pom-pom things?
Yeah, you want to add one of these?
Yeah.
Okay.
Okay. Oh.
Let me grab scissors really quick.
Okay.
Down here. So these are a bit trickier. Kind of want to put them.
Right.
Kind of skip one, put a pom-pom here, skip one, put a pom-pom there, skip one.
Like this.
So maybe I'll cut it here.
Like this?
Let me see. Yeah, And then go under, over.
Okay, but you skip one each
Yeah,
time.
see how I did it here? So
Oh.
one's over,
I see.
under. Kind of like a graph paper. Like you would shade this, like a checkered, right?
Uh-huh.
So color this one in, skip this one, color this one in, skip one, color this one in.
So Lorena, on average, how long would it take to do one of these projects?
It depends. So since he's a beginner, right? It's probably gonna take him probably like half an hour maybe to complete the whole thing. But if you're going bigger, it'll probably take a while.
Yeah, I was going to
Something
say,
like
because
this.
you have some on display that are pretty large,
Yeah, yeah.
and those are done by professional artists.
Yeah, and the loom was probably made out of wood. Like this, we're just using cardboard, something simple.
Right, a
like
lot larger than these
Yeah.
ones. So Lorena, if somebody wanted to find out some more about the Saturday classes you have, the exhibits that are going on at the museum, where would they need to go to?
Visit us at the bmoa.org.
All right. Thank you for coming in
Thank
this
you.
afternoon.
Thank
We certainly
you.
do appreciate everybody coming over from the Museum of Art and showing us how we can integrate art and mathematics at the same time.
Yeah.
We'll be back with more right after this.
Thank you. All right.
These pictures depict the magnificent
Almost
wonders
there.
of our planet. Yet, they weren't taken anywhere on Earth. Instead, they were captured by astronauts aboard the International Space Station to chronicle the fragile beauty and ever-changing landscape of our collective home. To date, over 4 million photos taken by humans from space have been collected, from the earliest days of the Mercury and Gemini missions to the ones taken aboard the space station, and all are freely available to researchers, scientists, and the public worldwide. These photographs are taken for many purposes, from artistic to the scientific, and have proven to have a wide range of uses. A powerful use of crew photography is to study changes to our planet over long periods of time. The Tashka Lakes and Lake Nasser in Egypt, for example, have been photographed on a regular basis from the station over the past 20 years. This is partially because the water levels in these lakes change dramatically on a month-to-month basis, constantly affecting agriculture in the region. Researchers, able to observe these bodies of water over a long period of time using crew photography, can ask, is their volume more or less stable over time? Or are they slowly losing their water? Andrea Wenzel is a geoscientist for the Earth Science and Remote Sensing Unit, who manage requests for crew photography. She notes the flexibility that a crew member offers when taking a picture of Earth. A satellite generally takes the same photos over the same locations in the same orientation over and over. Astronauts, on the other hand, can use different lenses to take photos with different fields of view, from close-up to wide shots. The cupola on the bottom of the space station allows for a panoramic view straight down, or the crew members can elect to photograph an image that includes the horizon. And because the space station flies an asynchronous orbit around Earth, it can capture images at any time of day or night. Wenzel notes that the Vietnam Glacier at the southern end of South America is a good example of a moving Earth feature being observed by crew photography over time. There's been a significant decrease in the glacier's length over the years, and the photos allow researchers to observe the path the glacier is taking and correlate that to climate change data. The crew can also be asked to capture an event like a hurricane, wildfire, flood, or volcanic eruption. This image shows flooding in Colombia. Wenzel says it was one of a series of photos that was used by international first responders to update their flood maps. As a result, they launched an operation to rescue the inhabitants of local villages who were stuck in place due to rising water. Astronauts often say the most remarkable thing about seeing Earth from the space station is viewing our planet across climate zones and continents without borders drawn on a map. Fortunately for those of us still on the ground, their photographic skills allow us to see what they see, now and over decades of time, benefiting all of us in multiple ways.
seeing changes over time, just fascinating with what they can do, and the cameras that the clarity and the detail that they're able to see
Yes.
that far into space. So once again, just fascinated with all of the NASA videos, as well as the ones that we get with the ocean, because that is just
Yeah.
mind-boggling.
Unexplored territory. Yes.
There's so much more to explore. In studio with us, we have Owen, a 4th grade student from Stockdale Elementary, did a little weaving and math. You're going to do a little bit more math in a moment, but Cam, who has a sawmill over on the Central Coast, gave us this board foot, which is how wood is measured. When people need specific things, they measure them out in board foot. So out of this, we were talking about how there were so many thousands of pencils that could be made from a tree. So if we took a regular pencil like this, how many pencils do you think we could get out of one board foot of wood?
Well, I'd say the thickness of it would be like 2.
Okay.
So, simplest way to do that. Like, has this been sharpened?
Well, indeed it has, right?
How long was it when it stood?
How long do you think it might have been? Not too much longer than it is right now, right? So let's say it's about that.
Okay.
So let's say because of the bracer and the tip that go on the end, and let's just say it's about that size when they make it.
Okay. Then, like, so about 2, maybe a little less than 2.
Okay, 1 and a
Let's
half
say,
maybe? 1 and 3/4?
1 and 2
1 and 7/8.
thirds. No, 2
I'm only
thirds.
seeing how specific you want to get there. Okay. All right, so we can get a little over 1. And how many, what else are we going to do? Because you said you could go 2 high probably.
Yeah.
So we can get a little over 2 pencils right here.
Yeah.
And maybe a whole one off of this end right here, right?
Yeah.
But what about the rest of this?
Oh.
What do you think we need
I
to do
don't
now?
know. It'd be
Well, if you can get
a lot.
2 right here,
They should measure board foot by square pencil. That'd help.
That's what
measure it
they
by
should
square
do.
pencil.
Yes.
How long do you think this is?
I'd say like, where's that ruler? you
Well, hold
used
on. Now,
earlier?
I don't want you using a ruler. I want you to think
Okay.
about it. How long do you think that is? It's
maybe
called a board
like-
foot.
A foot.
It's a foot. So how many inches would that be?
It's a foot board, so like 12. That's the
So it's 12
standard for a
inches.
foot. So like 12 by 12.
Okay.
Most
So
likely.
how many pencils do you think you can fit across the 12 inches?
Are you counting or just rolling?
He's doing both
Well,
at the same
I
time.
don't want to throw you off there.
Let's say like 16 would be half. So.
Okay, I was going to ask if you were going to do the whole thing or if you're going to do half or a quarter and then multiply it out.
And if you do 2 times like about 16, that would get you. That would get you 32.
About 32.
Yes.
So
And then you multiply like the width, which gets you 64.
good.
And then you add 1 for each of these, which would be,
About another 32, right?
yeah, 32 in total. So that would be 96.
So do you think it's safe to say that we could get 100 pencils out of a board foot?
Yeah, rounding up. About. Okay.
You feel good with that? Saying
Yeah.
we could just generalize and sum up, saying, estimating we could say we can get 100 pencils out of a board foot.
Let's say 90.
You want to go 90?
Yeah.
In case there's a little waste there, you run into a knot, something like that.
Well, that'll make the pencil more unique, right? Anyway,
right.
I just wanted to see how you would come up with an idea on how to estimate how many pencils you would get out of the board foot. You ready to show us another technique for equivalent fractions?
Yes.
All right, over to the board, young man. So select a number between 8 and 15.
9.
You went with number 9 again.
Oh.
You sure
likes
you
that
want 9?
No,
You can, it's fine.
I'll do 14.
14. 2 over 10. And 4. Oh, that was pretty good going back to the other problem. 2 over 10. And 4 over 5. 4 fifths. So you want to find out if they're equivalent first, and then maybe you can make some equivalent fractions to those also.
So 2 over 10 would be 2 over 10.
Well, remember your
4
strategy at the
over-
beginning of the show was to take the smallest fraction and multiply
Yes.
it, right? Which one's smaller in this case?
First, we're finding out if it's equivalent.
That's right. So remember you said you were going to take the smallest one and multiply it, right? Or the one that has the smallest numbers in it anyway.
No,
Which
we're
one has the smallest numbers in it?
Well, 2. is
It
the
does have 2 over
smallest
10,
number.
that's right. But you're looking at the numerators or the denominators that we were looking for the smallest ones?
The numerators.
Okay.
So 2 times 2 equals 4.
Okay. So you multiply times 2, I like that. And remember we talked about if you multiply times 2 on the top, you got to multiply times 2 on the bottom, right? But let's go the same direction. 2 times 2 is 4. So on the bottom, please make sure you go this direction as well when you're checking to see if these fractions are equivalent, right? So which number are you going to multiply times 2?
10.
That's right. And does 10 times 2 equal 5? Doesn't work, right? So in this problem here, if you didn't have those arrows going and you got a little confused, you might think to yourself, 5 times 2 is 10, that's true, but that would be going to the left on the top and to the right on the
Yes,
bottom, and
that
these fractions are not equivalent. Do you know which one is bigger?
Yes, it would be 4 out of 5.
There you go.
Good,
Even
nicely
though
done.
2 out
So
of 10
I'm going to
has
stop you
a
there, Owen, for
bigger
a moment because
denominator.
you've done some great work, and I wanted you to get some that were not equivalent. And for your great work so far today, you've got yourself a meal courtesy of our friends at the Broken Yield Cafe, so congratulations on that. So I have time enough for another problem, so erase the board if you would, please. And put 27 over 33. What I'd like you to do is find an equivalent fraction for that.
Okay, well, 27 over 33, you can multiply both of them times 2.
But you said you have another way of making an equivalent fraction. What is that way? You want to change colors? Show us what you'll do. What are you going to do to this to make it equivalent?
It's his.
Okay, well, what is
but
that strategy?
You could add a 0 to each number. The end.
The end. And that's mathematically sound because really what you're doing is you're multiplying 27 times 10 and 33 times 10. Instead of times 2, you'd multiply them both times 10 and that would add a 0.
And I like how you do that. And instead of multiplying by 2 where we get a larger fraction, I want you to get a smaller equivalent fraction than 27 over 33. And I will give you 30 seconds to see if you can come up with one. Smaller than 27 over 33. That's equivalent to it.
So how do we make it go this direction? If we multiplied to make it bigger, what do you have to do to make it smaller? What's the opposite of multiply?
Divide.
Divide. So what can you divide into 27 and 33? What's a
And
number
you've got
you can
20
divide?
seconds.
Well, I'd say...
Not 2.
3?
3. So real quick, what's 27 divided by 3? And you're thinking 9. What about 33 divided by 3? You could do that, right? 3 divided by 3 is 1. 3 divided by 3 is 1. 9 over 11 would be an equivalent fraction to that
Yes, it
one.
would.
So you can multiply it or divide it.
And we'll have to think about more of that stuff for tomorrow because John just come up with another way to do that. Owen, did you have some fun today?
Yes, I did.
Good. Glad to have you here. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.